Alright, everyone, so welcome back to chapter 53. This is part 5, and this is the final section for this chapter. Up to this point, we've been spending a lot of time talking about population size, their dispersion, their growth, really as it relates to animals and insects and plants and all of that. The last section of this chapter goes in and sort of takes a look at how does some of those concepts actually apply to human population growth. And this one you want to spend a little bit of time with because I've seen it show up multiple times in some form or another, particularly with respect to kind of free response questions on the AP exam. So take some time as you're going through the text and really kind of make sure you understand what the basic patterns were, why we had different growths, declines, and that sort of thing. So for the most part, if you take a look at this graph up here, all right, the growth of human population for much of our early history was pretty flat, pretty stable, and not a huge number of people. Until we hit about 1650, it was relatively slow growth. And once we get to 1650, we start to see that exponential explosion. So take a minute. What sorts of things are coming about at that time in history to cause us to start to see this population explosion? Well, if you think about it, that's really our start of a much more civilized society. We're really starting to come into our own with agriculture and cattle and sheep and having that livestock. And so now we're able to not just kind of have to be hunter gatherers, but we're farming and we're feeding communities and we're taking care of each other. And it's much more of a social dynamic that starts to allow us to get to that point. All right, of course, we see that little dip there. The plague is actually significant enough to be seen on this kind of large scale. All right. But after that, basically, the sky's the limit. However, we know that populations can't grow exponentially forever, and we're not going to be any exception to that rule. Okay? We're kind of going to be able to overcome a lot of it given our technology and medical treatments and that sort of stuff. But eventually, we're going to explode past that carrying capacity so far that things are going to have to get put back in check. All right, and the question is, do we make that determination as a society and try to starve off some of the potentially disastrous effects, or are we not? And in which case, is feedback mechanisms in the globe going to kind of take care of us? But, we start hitting Industrial Revolution and that huge increase goes on. And again, those increases are coming from all sorts of advancements in our capacity to grow food, to get it to other populations, us expanding outside of just Africa, into Asia, into Europe, and then eventually to the Americas, and our advancements in medicine. All right, it's no longer now where we start to see some slow growth, especially in your industrialized nations back in the 60s, where we started to understand that we no longer needed to have multiple children to ensure that kind of our family lineage went on. All right, at that point, we were talking about a global population of more than 6.8 billion people. And before that, you needed lots of children to help on the farm, and there was a lot more childhood disease that would kill off offspring, and so people had 10, 12 children. Where now, as we're getting more advanced and we're less of a agricultural society, those families aren't having necessarily tons of children. All right, the average family size is usually 2 parents, 2 children. versus those big, large families your grandparents were probably used to seeing. All right, and so we're starting to see some projection of decline. All right, and it'll be interesting to see how in your lifetime that decline continues to happen and how dramatic it truly ends up being. So in order to kind of maintain some more regional stability within human populations, we end up in one of two scenarios. All right, we either have a zero population growth because we've got a really high birth rate, but that gets stabilized out because there's a very high death rate, which was sort of where we were talking, earlier on here in history. Or we've got a zero population because we've got low birth rates, but we've also got low death rates, which is more where we are now in modern society. And so what we see is this sort of demographic transition where we're moving from that high birth, high death rate to more of a low birth, low death rate. We're still getting a zero population growth, or at least a lot closer to that. But we're not needing to go out and have 8, 10, 12 children because of our healthcare and education and technology, particularly for women, is starving off some of that necessity to have high births. And then as a result, we're also having low death rates as well. Okay, and so that's sort of where we are for most of our industrialized countries. Now your developing countries are still more in this kind of high birth, high death, but we're starting to see more and more transition over as we get more food there. We teach them how to better farm, or better to just be educated in general, more access to healthcare, so on and so forth. So what we can do with some of this data is actually develop these age structures. And these are kind of interesting because we're looking at the relative number of individuals in each category, and depending on the development of the country, we see different patterns. So a basic age structure, this is a developing country. All right, so high birth, high death rates. And if you take a look over here, here's sort of these age groups. All right, so 1 to 4 is here, so on and so forth, up to the top of this one happens to be 80 to 84. And what you start to see is that you've got huge numbers of pre-reproductive children. Okay, so developing country, they got very high birth rates, so they got a lot of kids down here. Here's your reproductive age groups. All right, so less than here, so we were obviously having a decent number of infant mortalities. Childhood disease is still a major issue. All right, so they've got to have all these children to ensure there's enough individuals here at reproduction, and then a high death rate up here, not nearly as many in that post-reproductive. They also will take it and kind of split it so that you see males on one side, females on the other. Right, and that becomes interesting when you start to see more on one side versus the other as well. So we can use these age structures to sort of help predict population growth trends, okay, because they're taking a snapshot of what that country's structure looks like in that particular point in time. And so when we see more of this kind of pattern, we're getting a lot of rapid growth, all right? So lots and lots of children in order to ensure we get to this stage. Where you've got slower growth in something like this particular structure, where it's a little bit more of a column, if you will. All right, and then here I've got even less children here than I have here, and so over time that's going to shrink as well. All right, and so we really start to end up seeing some of the societal conditions that these countries are going through, and from a government standpoint, these can be particularly useful in helping to plan for the future as far as, let's just use our country for example, healthcare costs, welfare, Medicaid, Social Security, all right, and sort of predicting All right, based on what I've got here and here, what should I expect this to be in 20, 30, 40, 50 years? We can also look specifically at just life expectancies. All right, and here they're looking at life expectancy for infants. And this is important, all right? If we're talking about developing countries, right, less education, less medical aspects, less access to good, nutritious food, their infant mortalities are much, much higher, and so their life expectancies are lower, all right? Whereas your developed nations, we've got very few infant deaths, and so our life expectancy is higher. So that life expectancy at birth is a great influence on the quality of life that individual faces as they get older. All right, also an interesting predictor as to what our population growth will look like over time. The last thing to mention is just this idea of an ecological footprint. So the whole point to looking at a country's ecological footprint is to take a look at how much land and water area, energy can get thrown into this is necessary for an individual person in order to be sustainable. And this really is coming more to the forefront because as our population was exploding, we talk about carrying capacity. All right, the carrying capacity of the globe in general for humans, all right, is still kind of uncertain. All right, but most scientists kind of come to an agreement of somewhere between 10 and 15 billion people. Currently, our predicted population growth expects us to get somewhere between 7.8 and 10.8 billion people by 2050. So we're not quite at carrying capacity yet based on most scientists' estimations. However, we're getting pretty close. All right, and so what is that going to mean as we reach carrying capacity? Probably get over it. Are we going to have the resources we continue to need in order to have the food we require, have the water we require, and then also have the land to take care of the wastes that we generate? All right, and that's a big deal. Chances are, if we continue at the rate we are going in the way that we utilize our resources, maybe not. All right, and so I think this is really starting to come to a head as we are really staring down the barrel of population growth and how do we ensure that that growth is sustainable. All right, and so that topic also comes back up a little later in our conservation ideas. So we'll come back to this, so keep this in mind.